I'm going to quickly go over the warm-up that you did here today in class. Let me zoom in a little. I might turn on the light. Maybe that's a little better. Okay. In 1, 2, and 3, you are just deciding if your slope is positive, negative, 0, or undefined. Well, this is a vertical line. That is a vux, so that means your slope is undefined. This, if you start on the left, you're going down, so that's a negative slope. Remember, slope dude, positive, negative, 0, undefined. This is a horizontal line, so that has a slope of 0. Remember that what looks like an O is actually a 0 in the HOI acronym. Okay, now on these, let me try to zoom in a little here. There we go. We have two methods when we're given a table of values. We can just use our slope formula where we put our y's on the top and the y's on the bottom. I actually chose to use these 2 points, and remember I recommend you write them on top of each other. My y's are lined up, so I just put those on the top. y2 minus y1 goes on the top. And my x's are lined up, so I just put those on the bottom. I have a double negative there. Turn that into a plus. Negative 6 plus 8 is 2. Another double negative. Turn that into a plus. 0 plus 2 is 2. 2 divided by 2 is 1, so my slope is 1. The other method you can use when you have a table of values is to divide your change in y by your change in x. This is in your notes when we first defined slope. So if you look at these, it looks like my y values are going up by 2 every time. Plus 2, plus 2, plus 2, and it looks like my x values are doing the same thing. 0 plus 2 is 2. 2 plus 2 is 4. Negative 2 plus 2. Negative 2 plus 2 is 0. So that means my change in y, which are these numbers right here, is 2. My change in x is also 2. So this one has a slope of 1 also. Okay, hopefully you got those. This is just graph. This is in slope-intercept form. I know that because the y is all by itself on one side of the equal sign. So this is my y-intercept. When you have a y-intercept, your x is always 0. So I want to go to negative 4 on the y-axis. Remember, start on the y-axis. M times x, your slope is always the number multiplied by your x. And remember, slope is rise over run. So I'm going to rise 1 and run 5. So from the point I already graphed, rise 1 over 1, 2, 3, 4, 5, put a point. Okay, I'm kind of out of room here, so I can't go more in that direction. I'm going to try to put one over here. So I'm going to go down and 1, 2, 3, 4, 5 to the left. Okay, now this is pretty flat. Do your best to draw a nice straight line. There we go. Make sure your coordinate points are visible. Okay, when I look at this one, y is not by itself. Notice the difference. Y equals. Here I have y minus 3. So I want y by itself. So I'm going to just add that 3 to both sides. It actually is pretty easy to get the y by itself in this one. I'm going to put this 4x first because I want it to be mx. I want that to be my slope, and I want my y-intercept to be hanging off the end. I'm going to rewrite this over here. So this is my y-intercept. And remember, any point on the y-axis always has an x value that is 0. So my first point is going to go right there on the y-axis. There's my slope. It is a 4. And remember, slope is rise over run. And then we said if you're missing a run, add a 1. So I'm going to rise up 4 and run 1 to the right. So up 1, 2, 3, 4, kind of ran out of grid here. 1 to the right, just do your best to figure out where that would end up. So I'm kind of adding a grid line there. Okay, now I got 2 points. I could graph it, but I'm going to do a point over here on the other side. So this time I'm going to do the opposite. I'm going to go down 4, 1, 2, 3, 4, and then 1 to the left. Okay, now draw your nice straight line. Ugh! I didn't do a very good job right there. Make sure yours goes through all the points and has arrows at the end. I want you to save this paper. It's got some good examples. You can use it for notes. And that is it for this video.